Hello everyone, my name is Evgeny, and today I'm going to start a series of lectures dedicated to recommendation systems. In this series of lectures, we're going to discuss some theory behind recommendation systems, as well as do some hands-on practice uh, to code our own approaches, as well as some popular approaches. In the first lecture, I'm going to introduce you to the theory behind recommendation systems. Well, not of it, but basic one. Then we are going to have some tutorial on how to set up everything, how to code these basic approaches. And then in the next lectures, we're going to dive deeper into some fancy words like collaborative filtering, ranking, multi-stage, and so on. The goal of this series is to give the knowledge and experience for everyone who wants to dive deep into the recommendation systems and sort of learn on how to apply it. The theory is for everybody, for anybody interested. These lectures don't require some sort of knowledge, but the practice is mainly for those who are familiar with the Python programming language, because this is the most used programming language in all of the machine learning, and machine learning is the area where recommendation systems domain also lives in. About me, I'm Evgeny. I'm an experienced machine learning engineer. I worked across computer vision, natural language processing, and recommendation systems. And my main specialization is recommendation systems. I worked at different recommendations. I worked at restaurants recommendations, at music recommendations, in the job matching platform where I ranked different employees as well as vacancies. And I also worked in social network feed personalization. And that's why I want to share my experience with all of you and discuss how it can be applied. I'm going to start with business applications where recommendation systems are used. And one of the first things is ads and search. For example, it is the main business area of Google. Then there is also e-commerce and retail, like for example, Amazon, eBay. Then there are also social feeds and content ranking, like Instagram, Facebook, YouTube, TikTok, and so on. You can also rank music, movies, and books. For example, in Netflix and Spotify. You can also rank some other domains like hotels, restaurants, groceries, for example, booking.com. You can rank jobs and employees as LinkedIn, and some other approaches like education, health, finance, and so on. Why recommendation systems are even needed? Well, it turns out that the better recommendation system you have, the more money you earn. And not only because of the best experience possible on your platform, but also you can sort of mix in some business rules. You can also mix in some, I don't know, for example, advertisement auction. When you search something on Google and you have sponsored results. Of course, we're talking about personalization. You're going to use the some social network where your interests are best captured. And also about engagement. When you're building some sort of platform, you want the users to be engaged on that platform. And the recommendation systems is one of the ways to do that. In order to get the sense of how and is even a recommendation system working on your specific case, you need to measure that. And in order to measure that, one of the most evident approaches is just to measure your money. Well, you have recommendation system, and then you have setup where you don't have recommendation system. And you can sort of compare them. Where do you earn more money, with or without it? But though the revenue is a good metric, it is often noisy, as it is impacted by many things. And there are other helpful metrics, like, for example, CTR, which is click-through rate, which you can also measure. And that is a metric which actually captures of all of the views for a specific user or for a set of user or for a specific search. Um, what is this probability of this view to be clicked in the real world scenario? What is the expectation? Um, then we also have conversion rate, which is also like CTR, but instead of just clicking, which can be clickbait, you don't always want to only increase clickbait, but you also want to have some other actions, like in Amazon, you don't want your items to be clicked, you want them to be ordered. So you can have different desirable actions like order, or for example, if you are listening to music, you can also have some sort of action as like, for example. These are three main metrics I've got used to see in my experience, but there are also another one. For example, you can just measure absolutes like number of orders, clicks, likes, listens. It depends on your specific case, domain, and platform. And you can also measure session time per user, listening time, watching time, because those metrics are usually also reflect how your users are engaged, because those are the main sort of time spent personalization metrics which you can measure. But you can't always measure only online, because then the cost of each experiment is very high. And suppose you have a new model and you want to test that, you will need to have some sort of offline proxy in order to test things and measure them offline. And usually for that, there are specific offline metrics um, which can be used. Usually those metrics are computed at K, where K is the number of items we take into account. And then each metric is computed for each individual user and then averaged across all users. Uh, at least in this series of lectures, I'm going to calculate them this way, but that's not always the case. Sometimes you need to average them across searches or sessions, or sometimes even don't not average at all. And why are they measured at K? Let's suppose you have some person who sees only 4 items, and then you have another person who sees more items. And in order to measure those two users fairly, you will choose some metric and some K, which reflects most of the most frequent uh, most frequent number of items per user or per search. For example, if you have an internet store where first page includes only 20 items at most, then a good choice of K will be to use 20 items, to use 20. But it always depends. Let's move to specific offline metrics. First offline metric is precision. This metric is mainly calculated on logged events. We have some items which are used, which are showed to the users. And from them, we have some relevant items, for example, clicked or ordered. Let's suppose we have a person who listened to 4 recommended songs, and from those 4 songs, he liked 2, second one and fourth one. And then precision at 4 is 0.5 for him. And if we measure precision at 5, then we will have the same answer, because in that metric we have most items shown um, at this particular k. And in this case, we have 4. That's why it is 0.5. And if we take 3, then we will have less precision, because in first 3 items, there is only one item that was relevant to the user. Second metric is hit rate. This is an easier metric for me, at least. And it actually answers the question, had at least one item from first k items the desired action. For example, in our previous case, if we were to measure hit rate at 4, we will have 1, and even hit rate at 3 will be 1, because there is at least one song that the user liked. And this metric is pretty straightforward. Third metric is less straightforward. Recall at k is also have number of relevant items at first k, but then the discriminator is not the total number of items, but this is the total number of relevant items. And it does answer a question of, out of all relevant items in the dataset, how many did we successfully include in the top k recommendations? I like to think about it that we have some sort of recommendation system which didn't in the past capture relevant items for the user. And so the user searched those items himself in the search and then liked them. So they became relevant to him in our logs. And then by training the new model, we can calculate if those new items, which were organically liked by the user, not from our recommendation system, were captured in our new algorithm, in our new model. There are also a lot of different popular metrics which are used for offline evaluation. We're going to dive deeper into some of them in our next lectures. And of course, for each domain, some metrics are more preferred than others. And it always depends on the domain, which metrics to use offline. When it comes to recommendation systems, this is one of the machine learning domains. And as it is in all of the machine learning, you need data in order to train your models. In our case, we're going to use Yandex Music dataset, which is a music events dataset from Yandex platform. And we will dive deeper into that in the practice tutorial. One thing I also want to discuss is how to validate your results in offline. We talked about the metrics earlier, but you can just train your model on the same data and then evaluate your metrics on the same data as your model was trained on, because that way you're going to end up in so-called data leakage. And your performance won't match the desired results in online, in production. That's why we need to divide our data into two parts, into training and validation part. And there are different approaches available for that split. First one is just separate by user. So you train your model on one users, and then you calculate your offline metrics on the others. Then you can just shuffle all the data. For example, use 80% of your data as training and 20 as validation. And then there is a preferred, at least by me, approach is a temporal split. Why is it preferred? And I think the most convenient in recommendation systems is because it reflects how test production actually works. And what I mean by temporal split is we have, for example, a month of data for our model, Then we can experiment with first 3 weeks, and then we can take the last week as the test set. Why is it even the case? Because in usual setting, you have some sort of data which is logged in, and you have the model trained on that data, and then your model is deployed, and it actually um, do its job on the data which it didn't even see before. And so this split is the most reflecting one of the usual production online setting. And finishing today's theory, I want to discuss what are the easiest and yet good approaches in recommendation systems. One of them is just to sample popular items. For example, if you have some sort of internet store, just to suggest iPhones. If it is Google, we can suggest some most visited sites, for example, YouTube. If it is music, we can suggest popular music. Then we also can suggest some new items, for example, new music, new sites, which were created not so far ago. For example, I usually see that YouTube also does this when it includes some new videos into your feed. Then we can also have some simple approach, which is a little harder to explain. But for example, you have some author on YouTube from which you like a lot of videos. Then a good opportunity for the platform is to use this author's new videos to you as the recommendations. And of course, some items with which you already interacted before. For example, some viewed videos, some most listened songs, or most liked videos, or already bought items, which you will need again, milk, eggs, and so on. This is all for today. Thank you very much for watching. In the next lectures, we're gonna dive deeper into the domain of recommendation systems, as well as code the discussed approaches. But for now, that's all. Thank you again. Bye bye.